Okay, this is 4-2 homework. Let's see. First problems, all you have to do is name the prism. You don't have to figure anything out. You just have to name the prism, which means you name it for the shape. So for instance, this has an octagon up here and at the bottom, so it's an octagonal prism. This has triangles at the top and at the bottom. Triangle, pentagon, a hexagon at the top and at the bottom, a square prism. Now, when you have a square prism where even the side, the lateral faces are the same, it's got a special name. It's called a cube. Yeah? Okay. Number 7. Will this net form an octagonal prism? Explain. Well, I'll tell you right there's a face missing. And if you look, you've got 1, 2, 3, 4, 5, 6, 7 faces. That means there won't be enough for the 8 sides on each of the bases. So, it won't form a prism because it'll be open. The base of a square prism is 60 inches squared. The height of the prism is 6 inches. What is the surface area of the square prism? Right? So, that means the base, right? If it's 16 inches squared, it's 4 on each sides, right? So you've got 4 and 4. The height is 6, so that means it's got 4 sides. Right, with 6 on a side. Right, so this one we already figured out, right? It was 16 inches. Now 4 times 6 is 24 inches squared. 24 inches squared. 24 inches squared. 24 inches squared. And we're done. Add all that up, and you get 128 inches. The perimeter of a base of a octagonal prism is 8 feet. What is the width of the rectangular side of the prism? So you got your rectangle, your octagon, and assuming that it is a regular octagon, unlike what I'm drawing here, each side is going to be the same. If each one is 8 feet long, that's 8 divided by each one. There's only going to be 1 foot per side. Base of a triangular prism has an area of 6 centimeters squared. The height of the prism is 5 centimeters. The width of the rectangular faces are 3 centimeters, 4 centimeters, and 5 centimeters. What is the surface area of the rectangular prism? Well, and here they're just being a big old pain in the neck. Right, so just give me a second. We're going to erase all this nonsense. Blah, blah, ginger, blah, blah. Right. Okay. So I'm just going to draw the net. The base of a triangular prism has an area of 6 centimeters. 6 centimeters. Right? The width of the rectangular faces are 3, 4, and 5. We know that its height is 5 centimeters, so that's 5 by 5. That's 3 by 5. That's 4 by 5. And then up here is the top base of the prism, which would be another 6 centimeters squared, because both bases are the same. So, when we multiply 5 times 4, right, we get 20 centimeters squared. 5 times 5 is 25 centimeters squared. 3 times 5 is 15 centimeters squared. Put these two together, you get 12 centimeters squared between the two of them. 20 and 25 and 12 is 72 centimeters. Okay, so now we're done with this. Okay, we look at the back. Right, she gives 3 customer haircuts in 2 hours. Right, so if it's 3 to 2, then that means that it would be 6 to 4. Hold on, wrong symbol. 3 to 2, 6 to 4, double the 6, that's 12. That would be 8. And so it would be 12 customers, 8 haircuts in 8 hours. All right, we complete, we add them together, find the common denominator, and then add them up, and then simplify. Common denominator would be 60, you add them together with the remainder, it becomes 1 8/15. Here, because you're adding, you line up the decimal places, 56 plus 23, and 4 4/7. Here you multiply, making sure that you have, because you have 1, 2 numbers behind in the decimal place, you have 1, 2 in the answer. Here you're dividing, so you would to make this into an improper fraction, and then multiply by the inverse, which would be 3 twos in this case. You'd end up with 2 7/10. All right, 607.3. We would subtract that from 122.9, lining up the decimal places because again it is subtraction. Here we would just make this an improper fraction, and then we would do the subtraction and then reduce, and it would give you 2/3. Again, the division, we would have to move over the 1, so it would end up looking like 30 divided into 134.1. 15 which would then give you 44 1/7. 15.4 plus 15.6, you'd add them up, lining up the decimal places, and get 71. Here we just have to find the surface area. Right, you find all 6 faces, they add up to 148. All 6 faces add up to 992, 410. This one, Haruga makes boxes for games that she's invented. She makes a box for 1 game. Then she makes a box with the dimensions are 1/3 the dimensions of the first box. What is the relationship of the surfaces between each box? So, right, she makes, here, let's just start over here real quick. Right, she makes 1 box. Right, looks like this. She's got height of 3, length of 9, width of 6, right? And then she makes the same box, right? Only she makes that are 1/3, right? So it would be a little bit smaller, right? So this would be 3, 1, and 2, right? Each dimension is 1/3 of the first box dimension, so when you multiply the two dimensions, the product is 1/3 or 1/3 or 1/9 of the first surface box's area. So since each one of these is 1/3 of 1/3, it's going to be 1/9 of here, and we can prove that. 3 times 9 is 27, right? So this face would have been 27. 1 times 3 is 3. That is 3 is 1/9 of 27, right? 2 times 3 for the top face is 6. 6 times 9 for the top face is 36. No, 54. 1/9 of 54 is 6. So the original box is 1/3 the area of the first box. And that's it.